In this video we are going to see how to determine a potential function of a conservative vector field. We are going to see that through this problem. Let's look at this question. This question is asking, say whether this vector field function is a conservative vector field. If it is, find small f function such that the gradient of the small f function is equal to vector field function. Here we have the vector field function. Now to prove this one is a conservative vector field function, what we had to do is we had to prove that scalar curl is equal to 0. To find the scalar curl, what we do is we put this as f1 and this one as f2. The values before I component and the values before j component is f2. Value before I component is f1. Now what we do is we take the partial derivative of f2 respect to x and subtract f1 respect to y, and this is our scalar curl, and if this is equal to 0 it means this is a conservative vector field. Now let's go ahead and do that. Now let's take the f2 partial derivative of f2 respect to x. So in our case f2 is equal to e power x plus x cos y, and we are going to take the partial derivative of this one respect to x. If we do that, e power x, derivative of e power x is going to be e power x, so this just remains the same. And if we take the derivative of x cos y respect to x, this x will turn into 1. This cos y will be treated as a constant, so that's going to remain the same. So this is going to be just cos y, okay? Now we are going to take the partial derivative of f1 with respect to y. This is our f1 value, y e power x, partial derivative y e power x plus sine y, and we are going to take the partial derivative of this one respect to y, and if we do that, this y will turn into 1, so we will just have e power x right here, and this sine y, derivative of sine y is going to be cos y, okay? And from this one you can see these two are equal. This is our partial derivative of f2 respect to x, and this is partial derivative of f1 respect to x. These two are equal, right? We have equal values, e power x plus cos y, e power x plus cos y. So if we subtract these two, this is going to be 0. This means this is a conservative vector field. So that's our first part. And also there are like two things you have to confirm. You have to confirm the scalar curl is equal to 0, and also we have to have this function defined everywhere. So there are three conditions you can have undefined. Like when you have a denominator is equal to 0, that's one condition we can have undefined, but there's no denominator here, so there's no way we can get denominator equal to 0. And also another condition that if we have a negative value inside a square root, that's also undefined. We don't have that one right here. And also if we have ln of 0 or negative value like less than 0, that's also undefined. We don't have any of that situation. It means these functions are defined everywhere, right? So it satisfies both of the condition. It's 0 and defined everywhere. It means this is a conservative vector field. Now the second part is, if it is, find f such that the gradient of small f function is equal to vector field function. Now to find this function, what we do is, now instead of writing like this, let's put, now we are going to put this one as p, this one as q, okay? This is our p, this is our q. Now what we do is we take, this is our p function, y e power x plus sine y, and q function is e power x plus cos y, okay? Let's choose a different color. Now what we are going to do is we are going to equate this p function to partial derivative of small f function with respect to x. So this is going to be y e power x plus sine y, and then we are going to equate this q function to partial derivative of small f with respect to y. So this is going to be e power x plus cos y. Then to get rid of this x, what we are going to do is we are going to integrate this one with respect to x. If we do that, this is going to be just y e power x, and if we integrate this one respect to x, e power x, integration of e power x, that's going to be just e power x. So this is going to just remain the same, y e power x, because y is a constant. that's not going to do anything, so e power x remains the same. And if we integrate sine y respect to x, this is going to become x sine y, x sine y. And also, since we are integrating this one with respect to x, we are going to have g of y function. Okay, now what we have to do is we have to find the g of y. This is our f of xy, right? This is the question asking. Question is asking to find out the function such that the gradient of this function is equal to vector field function. Now this is our function, but we cannot write like this. We have to find this, what is this g of y value. Then that's going to be the final answer. Now to find the g of y value, what we are going to do is we are going to take the partial derivative of this one with respect to y. So if we take the partial derivative of this one respect to y, this y is going to become 1. So we are going to have e power x, and then this x is a constant. This sine y will turn into cos y. So we are going to have x is a constant, sine y will turn into cos y. And I forgot to copy this x cos y here. This is x cos y, okay? Because our q function is e power x, x cos y. So if I take the partial derivative of this one, this is going to turn into x cos y, and this will become g prime of y. And if I compare this one with this one, you compare these two, and you can see we have e power x, x cos y, x cos y. But g prime of y, we don't have that one right here, right? So from this one we can see this must be equal to this one. So if this is equal to this one, it means g prime of y should be equal to 0, because we don't have any value after this. So this g prime of y should be equal to 0. Now to find g of y, because our purpose is to find this value g of y, to find that one we have to integrate this one with respect to y. If you do that, you're going to get a constant, because we have 0. If you integrate a 0, that's going to be constant. Let's put that one as k. So our final answer is going to be f of xy is equal to y e power x plus x sine y, and this g of y is going to be just a constant, okay? And that's going to be the function such that the gradient of this function is equal to vector field function. And that's how we do this kind of problems. I hope this helps. Thanks for watching.